So today we are going to cover SQS, Amazon S. Okay. So today we are going to cover Amazon SQS. What is Amazon SQS? Where can use it? Okay. So Amazon SQS is one of the first service which Amazon has launched in 2006. Okay. This is one of the first service which they have launched in 2006, which is used to queue the messages. Okay. What is mean by queue the messages? So we have talked about data. Data means files. So where we are storing files, we are storing file in S3, we are storing file in EBS volume, we are storing file in AFS and other storage as well as in RDS machine. We are storing data in database. So we have so many storage services are available. But if I want to store the messages means the WhatsApp message, the email message, or the text message which you are receiving on your mobile, where can I store that message? That message can be anything. That message can be anything. The message can be about the task completed by one machine. One process has completed, and the second process needs to start. That type of message, or as application is sending broadcast message or notification on your mobile that this is a new offer. Okay, anything can, like a good messaging service which you are using on a daily basis. Can anybody give me example? Your Gmail, your WhatsApp, where the the producer, basically the party who is sending the message, sends the message, and that message is received by your application like Gmail, your WhatsApp, and it stays there. It stays there until you read or you delete the message, until you perform an action. Same thing in the cloud. If some producer, okay, if some machine is producing some messages, this is some application, right? This machine is producing some message like the task is running, task is completed, task is failed, and you want to capture this message, capture this notification. So you can create SQS queue, okay, and store these messages here. Why you not want to store these messages? Because it's not always that you are going to synchronously can receive the message. Okay, one of the other example is there are two machines. There are two. Let's say two persons are there. Okay, there are two people who are doing some task. This person is performing task number one, and this person is performing task number two. Now, until and unless task one is completed, task two cannot be start. Okay, task two is dependent on task one. Let's say task one is completed, but task two didn't receive the message from task one. So what will happen? It will be waiting for the task one to complete it, right? Somehow the message got lost. So there is, because of network issue, because of some other issue, the message didn't receive to task two. The task two didn't start. It is synchronous. They are waiting. Task two is waiting for task one to complete. Okay. This is one example. So what you can do? You can store the messages here. You can store the message in queue. So task one will send a message in SQS. Task one will send a message to SQS, and task 2 will keep on checking, is there message available, is there message available. Now here one more advantage of using a queue. Let's say task 1 is doing task very fast. At a time it is completing 4 tasks, but task 2 is only able to handle task 1, only able to handle one task. The process 2, okay, the second application is only able to handle only one task at a time. So what will happen with the remaining 3 tasks? Either application 2 need to preserve this information somewhere, or it will be lost. So that's where queue will come in, help in picture. You can store all the 4 messages here that task 1 has completed. Now task 2 will pick one message at a time and will complete that task. So this is how basically SQS works. It is a message queuing service. You can put anything on this and you can leverage it when you want to create a buffer in your application, buffer in your system. Then one task is completed, one process is completed, and second process needs to start. And if you want to create a buffer between them, here one more scenario is there. Let's say task 1 is running, application 1 is running, and application 2 is running. Now previously application 1 was running very fast and application 2 was running slow. That's why we introduced SQS, right, to preserve the message. Now the scenario can be application 1 is running very slow. At a time it is producing only completing one task, whereas application 2 can handle 10 tasks parallelly. Now if you are just feeding one task to application 2, this two task application 2 will complete the task within 10 minutes, or let's say in 6 minutes. Now application 2 has to wait for application 1 to complete the task, and here we are running that application. So let's say this is EC2 machine. So you are just wasting your resources by waiting for application 1 to complete the task. So what you can do, you can store the message in SQS and don't run the application 2. Don't run application 2. Now in SQS you can configure a autoscaling. We have learned about autoscaling. So if in SQS there are, let's say, 12 messages are received, 12 notification, 12 completion task received, then only trigger the application 2 and start application 2. As soon as application 2 starts, it will start receiving messages. So you are buffering. So don't, here what we are doing, we are saving our money. Okay. So SQS is a web service that gives you access to a message queue that can be used to store message while waiting for computer to process them. Okay, we store the message and we store the messages. These messages are waiting in queue so that some application, some uh, process can consume them and process them. Some application can consume them and process them. It is a distributed queue system that enable web server application to quickly, reliably queue message that one component in your application generates to the consumed by another component. So as I said, there will be one application which will be pushing the message into the queue, and there will be another component which will be pulling the message out of the queue. So this is a producer, this is generally called consumer. A queue is temporary repository for messages that are waiting for processing. Simple. Messages are are stored there and they are waiting for to process. Now take an example. This is an image. This is an image. You have an application where you want to give some meme on this image. You want to add a meme on this image. Okay. Now assume that you have so many images coming in your website. So many tasks needs to be done. So as soon as a user uploads a file in S3 bucket, let's say there are hundreds or thousands of files are uploaded simultaneously. So you won't be able to process all these files together. So what you can do? You can push this images information metadata to a queue that this number of files has received. Now, as soon as a threshold is reached, let's say 50 messages are received, or in a day you're just running this EC2 machine one time in a day, or on the basis of threshold, let's say 50 messages are received, then only you spin up a EC2 machine which will pull out all the messages one by one, process them, and push it to another S3 bucket. This is a simple application. Okay, this is how you might have seen nowadays you can convert your application, you can convert your document into different formats. Okay, so this is behind the scene, this is how the system works. Even you have seen that they ask you to wait for a couple of minutes and they will notify you. So they what they do, they take your request and they put it into the queue in the waiting list. As soon as your message is pulled by the consumer, it will be processed. Now the advantage of this queuing system is that if let's say your producer goes down, still your messages, still your requests are preserved in the queue. They are not lost. There is no loss in your messages. Same one more example. Let's say you are booking a flight, or you are planning for holiday trip and you need your itinerary to be planned by a website. Okay, so you are the user, you have raised a request that I need to plan for my trip to Maldives. Give me the latest package. Give me all the information. You have given the requirement that this is my budget. This is my preference, and your request will be stored in SQS. So this is a website which you are accessing, which is hosted on EC2 machine. Okay, and your request is published in SQS. Now there will be a separate team, separate machine, which will be taking this request and generating the itinerary for you. Which will this machine might to search different website, different resources, like which is a best hotel, which is a courier transport service, what type of airlines will be preferred for you. It will pull the information from different service, different application, and it might take time for to process a single request, and then it will return back to you. Okay, so all you might have seen the you have to submit your requirement, and after some couple of minutes they will mail back you the requirement. Why they don't go instantaneously? Because they might require more computing power, more information gathering, and then after gathering the information they are reverting back to you. But right now you are one customer, similar to you there can be hundreds of thousands of customers which might be submitting their request to the traveling website, and handling all the thousand requests parallel is not possible. So to make sure all the requests are saved and preserved, you can use SQS. Always remember, SQS is a messaging service, not a data service. Here you have to put the messages. Okay. Using SQS, you can decouple the component of an application so they run independently, easing message management between the components. So we have talked about that. That when two components are running, if you want to decouple them, you don't want to run them synchronously, and you want the one application to be running and other application to be running independently of the first application, you can use SQS. If you notice the word decouple in the exam or in interview, just directly think of SQS, because that's where SQS come in picture. Any component of a distributed application can store the message in fail-safe queue. This is their fail-safe queue. SQS is fail-safe queue. What is the size of message you can put into SQS? A single message can be have character up to 256 kilobytes. So single message length can be go up to 256 kilobytes. It's a very huge. Any component can later retrieve the messages programmatically using Amazon SQS. So now there will be one producer and there will be one consumer. So the consumer will consume the message anytime afterwards. You don't want to consume the message immediately. The message can be consumed after some interval. What is okay? SQS acts as a buffer between component producing and saving data and component receiving the data for processing. So in industry, even my company, we are using SQS extensively for creating a buffer. So one component is producing something and it is notifying in, and we are not saving that notification in SQS. Okay, if the number of SQS if the number of messages in SQS increases, let's say after 20 messages we receive, then only we trigger the second component. So this is first component, this is first service, this is second service. Ideally, we can uh, run these services in sync. That task one is completed, it should be handed over to task two. But we don't want task to be running if task one process the data slowly or it takes longer period of time to complete a given task. So the application one or the process one can work independently, the application two can work independently. This means that the queue resolve the issue that arises if the producer are producing work faster than the consumer can consume or can process it. If the producer or consumer are only intermediate connected to the network. और वो लोग भी and second advantage is that the both the applications should not be working right now. So temporarily you can shut down the second application. You can shut down the first application. It's not always that the both the components should be up and running. There are two type of queue. Okay, so this is a category of the queue. First is standard queue and other is FIFO. So before that, let's go to your console. Let's go to console and create a queue. So meanwhile, our website is also up. We can work on that, but we'll cover that on Monday. Okay. Now you just go to SQS. You can see there is only one tab. Create a queue. There are two type of SQS. One is standard, another is FIFO. Okay. Standard means it's a standard. Basically, it is a fast queue. It can process uh, n number of messages together. Okay, the property we will cover in theory. FIFO means first come first out, first in first out. So here the order of the message is preserved. So the message which is received first will be going out first. But in standard, message can be delivered without any ordering. Okay, order is not preserved. So my okay. Now there are some properties. I will explain you in some time. What are the properties? Just right now create a queue. Standard queue. I am creating a standard queue. Okay. So this queue is created. Now let's say I'm a producer. So right now I'm in console, but your application will connect to this queue programmatically. So this is your queue. Now first your producer will send a message to this queue. Let's say right now I am doing that from console. Okay, here you can see send and receive. Okay, ideally it will be done by programmatic way by some code. Okay, so I'm testing a message. Okay, message 1, message 2, message 3, 4, 5. So let's assume that producer has sent a message. So you can see now 5 messages are there in your queue. So 5 messages are resting. So somebody has sent 5 messages. 5 information is there in your queue. Now let's say a threshold has reached and your consumer applications start asking the message from the queue. Okay, your consumer, your the second application wants the message. So again, here sending the message, here you can see receive the message. So this is inlet, this is outlet. So the consumer will ask the message from the queue. Consumer will ask the message from the queue. So receiving message. So they have to pull the message. Here we have to send the message. While sending the message, producer will send the message. Consumer will pull the message. Agree? Consumer will pull the message. Okay? Pull for a message. Now you can see SQS starts returning the messages which are received. Okay, this is a message. If you click here, you can see the body message 5. If you click here, message 3. If you click here, message 1. Okay, now these messages are will be stored in SQS until you delete them. Okay, until you delete them, these messages will be stored. It's just like your WhatsApp or your Gmail message. So your Gmail, your messages or mails which you receive on Gmail, you can go and check the message anytime. You can check the mail as per your convenience and you can take action. The producer are sending the mail. The person who has sent a mail to you will send it and the mail will be landing on your Gmail account or your WhatsApp application. Now it's your feasibility that when you want to access that messages, you can check one message at a time, you can check multiple messages at a time, you can delete them, you can take action. It's your choice. Okay, so let's understand the difference between the two queues. We have two type of queues, standard and FIFO. So standard queue are default queue. A standard queue let you have nearly unlimited number of transaction per second. Okay, so you can send unlimited number of messages in the queue. Standard queue guarantee that the message is at least delivered once. Occasionally, because of high distributed architecture that allow the high throughput, more than one copy of message might be delivered. Okay, so what Amazon does for standard, it just like S3, it's create multiple copy of your message. and you can see one, two, three message, multiple copy of messages are preserved in the queue. Okay, so and there might be chances when you are pulling the same message can be delivered twice. However, standard queue provide best effort ordering which ensure that the messages are generally delivered in same order that they are sent. Okay, so advantage of standard queue that the message will deliver only once. Oh, sorry, it advantage of standard queue is that you can send unlimited number of messages. The data is redundant. The only one problem is that it can deliver same message multiple times. That come FIFO. FIFO basically it preserve the order of your message. So the most important feature of this queue type is FIFO, first in, first out. Just like your line in your DMARC. So the person who has come first will be going out first. And the message is processed only once, exactly once process. The order in which the message is received and send and receive is strictly preserved, and the message is delivered once and remain available until the consumer process and delete it. Duplicates are not introduced in the queue. FIFO queue also support message group that allow multiple order message group within a single queue. The problem with FIFO is that the FIFO has a limit of 300 seconds transaction per second, but have all the other capability of standard queue. So FIFO is slow as compared to standard one. Now, what are the things you have to remember while learning about SQS? SQS is a pull-based service, not push-based. That means this is SQS. Okay, this is SQS. So generally, Amazon says that this is a pull-based service. You have to pull the message out of SQS. You have to pull the message out of SQS. Message size are of 256 maximum. It support up to 256 message size. Message can be kept in queue for 1 minute to 14 days. The default retention period is 4 days. So after 14 days, the message will be deleted. But by default, the property is if you put the message into SQS, by default after 4 days, that message will be deleted automatically. There's a retention period. So if you put a message in SQS, if no action is taken on that message, if no action is taken on that message, Amazon SQS will automatically delete that message after 4 days. You can configure it up to for 14 days. Okay. So how can we do that? Go to your queue. Okay. Okay, here you can see message retention period is 4 days. You can edit this and you can change it to from 1 minute to 14 days. So the message which is received in SQS, if no action is taken, it will delete it after 4 days automatically. You can change it till 14 days. This is again interviewer exam question. Now next topic is visibility timeout. Okay. Now this is important part. How SQS works in real world. Let's say you have a queue and in queue okay, let me open a paint. Okay, this is queue. Here you have message number one, message number two, message number three, message number four. You have three EC2 machine running. EC2 machine number one, two, and three. And let's say one more message, five. Right now, EC2 machine goes to SQS and asks for the message. So EC2, the SQS, and this is EC2 machine or any application. Okay, EC2 machine goes to SQS and it asks for message. So SQS will give message number one to this EC2 machine. Right? It will give the message. Okay, this was a message. When EC2 machine number two goes to SQS, now let me know which message should be delivered to the EC2. One, two, or any other message. Ideally, which message should be delivered to EC2 to number two? Should it deliver message one again? So answer is no. And how SQS preserve that? So as soon as the message one is delivered to one consumer, this message will be hidden. Will go in uh, deactive mode. So let's say make it color is red. So this is in red state. So this message will not be delivered to any other EC2 machine until for a given number of time, let's say 10 minutes. Next, okay, so this message will not be delivered to any other consumer. So if EC2 machine 2 asks for a new message, the message number 2 will be delivered to, apart from one, any message can be delivered. Let's say message number 3 is delivered to EC2 number EC2 second EC2. So here it will be in hidden state now. Now if EC2 second EC2 machine asks for a new message, which message will be delivered? Anything which is not read. So let's say this message is delivered to EC2 number 3. So now you can see three messages are in hidden state. Okay. Now EC2 number 1 has completed its task. Okay. And in how much time? Okay, we'll talk about that. Okay. So EC2 number 1 has completed its task. So now this application needs to delete that message. Delete this message. This message is the task is mark this message as done. So delete it. Now it will ask a new message from the queue. So we will deliver message number 2 to this EC2 machine. Okay. So this message will be delivered to 2. Now, meanwhile, you found out that this EC2 machine has gone down. This EC2 machine has gone down. It was processing message number 3, but somehow this machine has crashed. Now what will happen to this message? What will happen to this message? So that is called visibility timeout. So that means SQS will wait for machine to delete this message for, let's say, 5 minutes or 600 seconds. So if no action is taken on this message which is hidden until 600 seconds, then this message will be available for processing again. This message will be available to process again. So now let's assume that task 5 is completed. EC2 machine has completed task 5. So it has deleted that task 5 from queue. Now it will ask for a new task, new message. So SQS will deliver this message to you, to 5. So it will be consumed by EC2 number 3. Is it clear? So this is how what is called visible timeout. So visibility timeout is the amount of time that the message is invisible in the queue after a picker picks up the message. Reader picks up the message. Provided the job is processed before the visibility timeout expires, the message will then be deleted from the queue. However, if the message is not processed within the time, the message will become visible again and another reader will process it. This could result in same message being delivered twice. The visibility timeout you can set is 12 hours, up to 12 hours. Okay, so you can see by default it is 30 seconds. A message will be hidden for 30 seconds by default. It is called visibility timeout, and after 30 seconds, if no action is taken on the message will be available to read again, and you can set it up to 12 hours. Okay, SQS guarantee that the message your message will be processed at least once. Amazon long pulling is a way to retrieve message from SQS. What is long pulling? Basically, this is your SQS. This is your application which is pulling the message. Let's say there is no message in SQS. So what you will do? You will close the connection. Okay, take example right now. You have gone to a government office and the government officer says that right now it will take time to process your request. Come after 1 day or come after 2 hours. What you will do? Either you will sit there or you will come back. If your home is near, you will come back. If your home is far away, so you will sit in the office for 2 hours, right? You will not come back home for and go again after 2 hours or 3 hours. Similarly, this is consumer. Consumer has asked a message from SQS. Ideally, if there is no message, this connection will close. Request will again SQL will send a message like no message, zero message, close the connection. There is no message, close the connection. Now after 5 minutes again you will send a request to SQS that do you receive the message? SQS say no, there is no message. Then again after 10 minutes you will send a request to SQS, is there a new message? You will say no, there is no new message. So this is called short pulling. That after the immediately SQS will return that there is no message to the consumer. Okay, immediate response is called short pulling. There is called long pulling. Like you send a message to SQS request, is there a message is there? So if there is message is available, immediately it will be delivered to the consumer. But if there is no message, SQS will not close the connection for next 10 seconds. Assume that for next 10 seconds, SQS will not close the connection. So within 10 seconds, if a message arrive in SQS, it will be delivered to the customer or consumer. Previously, the connection was closed within 1 second. Previously, the connection was closed within 1 second. Now, the connection was running for 10 seconds or let's say 100 seconds. Why we are doing this? Because there is charge associated every time you hit SQS. Every request will be charged. If you're not getting anything, still you will be charged. So better to have a long pulling. So when you read a message from SQS, when you read a message, you can see pull a message. So you can now you can see the message are pulled. It is not only taking 1 second, it is pulling continuous pulling the message. Continuous pulling a message from the queue. This is called long pulling. Okay, the short pulling means a message you hit a SQS and it return the response immediately with a message or without a message. It's called long pulling. Long pulling is a way to retrieve message from SQS. With a regular short pulling return immediately. Short pulling will return the request immediately. Even if the message being even if the message queue being pulled is empty, long pulling does not return a response immediately until the message arrive in the queue or long pull time expires. Anytime you see a scenario based question about decoupling, directly think of SQS. This is all about SQS. Nowadays, Amazon is not directly asking a question on SQS. I have seen very less question on SQS, but still you should know. The next service is SNS. You have seen SNS and SWF. Okay, let me quickly cover these two services. SWF. Okay, this is a simple service, simple workflow service. Okay, just imagine right now you are ordering anything from Amazon. So you have seen that the flowchart is created, a task is created when as soon as you place an order, the task is created. First task is payment. Second task is notifying the warehouse person. Okay. Third task is to deliver it to you. The flowchart is created, something like this. Okay, verify your order, credit card. This is a flowchart. You order something, that order is verified, then you have to pay for that order. It will be shipped to you, record is completed and task is ended. This is a task creation. End-to-end workflow. If you want to create end-to-end workflow which involve machine as well as human, so this task is be done by human and this task can be done by machine, like confirming your payment, verifying your the order. So if this is your requirement, you can create using simple workflow. Simple workflow is a web service that make it easy to coordinate work across distributed application component. If it is a way of coordinating work across a whole bunch of different components within your application. SWS enable application for a range of use cases including media processing, web application backend services, business process workflows, and analytical pipeline to be designed as a coordinated task. Tasks represent invocation of various processing steps in a application which can be performed by executable code, web service, or human. So basically the workflow can be, if you have defined this workflow, if you have created this workflow, this task will be done by machine, this task is done by the machine, this task will be done by human and will be marked done as done, and this task will be done by machine again. So this is called SWS. You can create a workflow. So SQS has a retention period of 14 days, whereas SWS has a retention period up to 1 year. So if a task is created, let's say you have ordered something. If you have ordered something, your order, after placing the order, it can take 10 days, 15 days, even months to that order to be get completed. So the task can be paused between for some time. So SWF present a task oriented API, whereas SQS offer a message oriented API. API. SWS simple workflow ensures that the task is assigned only once and is never duplicated. With SQS, you need to handle duplicate message and may also need to ensure the message is processed only once. SWS keep track of all the mess event, task and event in application. With SQS, you need to implement your own application level tracking, especially if your application using multiple queue. So in SQS, you have to write a consumer, but in SWS, everything is automated. So these are three component of SWF. One is workflow starter, application that can initiate or start the workflow. So if you are ordering something, okay, so as soon as customer orders something, this workflow will start. If customer is just browsing, this workflow will not start, will not be created. So that's called workflow starter. Could be your e-commerce website following the payment of an order of your mobile app searching for the bus timing. Okay. Yes, yes. Order processing, you can create the workflows. Yes. Okay. So again, it's a chargeable service. You have to create so many things on for that. I will just show you. This is a workflow. Okay. You have to create a domain again. You have to create a domain for first. But let me show you the. Okay, they have changed the geo again. So it's a fully managed task tracker. Helps you to develop and build a background job that can run parallel sequence steps. Okay. So introducing, they have changed the geo. Previously it used to have a diagram here. Okay, and same service is step function. In industry, your people are using step function extensively. So there are multiple function. So you have to register a domain first of all. Let's say abc.com. Again, it's a chargeable service. Okay, now after creating the domain, you have to define the workflow. You have to create a workflow, register a workflow, create a workflow. Then you have to define the steps. You have to define the logic here. So here are activities, and you can execute it. You can run that workflow. So you have to design that pipeline first. Okay. So how can you design? You have to register that workflow. Okay, and you have to add the activities in this workflow basically. Okay, you can see the actives, duplicate. You have to add the activity, register the activity, and add that activity in your workflow. Okay, so even I have tried, because in industry it is not that much used nowadays. People are using this service called SQS. So step function. So step function is another service. It is a orchestration service. So this is how the step function works. Task 1, task 2, task 3, task 4. So let me check if I have a diagram available for the step function which I have created. Okay, so I will just show you one application which I have designed. So this is a step function. So if you start a job, you can see the start button here. As soon as the job starts, it will start executing the flow. So here the first is to run one application, second application, third application, fourth application, and then it runs. This application is designed by me. So here again it's a task based orientation. It's a flow, just like the pipeline which you have seen right now. in our PPT. Okay, so in SWF you can integrate with human as well. Okay, but it is very rarely used service because it's mostly used in e-commerce website, not in for data processing. For data processing for task or in the cloud, mostly people nowadays using SQS. Okay, it's very powerful tool. Now coming back to SWF, it has a decider. Decider basically means control the flow of the activity task in a workflow execution. If something has finished or failed in the workflow, a decider will decide what to do next. Right? If the payment failed, do you will place the order? No. If the inventory is not available, will you process further? So answer is no. So this is how the decider will decide what to do next. Okay. Carry out the activities. Activity worker basically means they are the worker, they are the main component of your workflow. So always remember, nowadays less people are using SWS, but in the as it is a part of the certification, we have to cover this topic. But yes, there are many other services which are launched, which is again are not right now in the part of the certification, just like step function or pipelines, data pipelines. There are so many things in cloud. Okay, let me quickly cover the last topic, SNS, and the final part is SNS for today. So what is SNS? We have used SNS. It's a simple notification service in cloud which is used to send the notification, to send the messages to different people. Okay, so SQS is a simple notification service in web that can make easy to set up, operate, and send notifications from the cloud. It provides developer with a highly scalable, flexible, and cost-effective capability to publish a message from application and immediately deliver to the subscriber. So basically, it's a broadcaster. It broadcasts the message. If you want to broadcast a message to your email ID, to your mobile, as a flash message, as a pop-up message, you can do with SNS. So if a task is completed, it can send a notification, and that notification can be sent to multiple devices like your mobile, your email, even SQS, okay, and other service. Okay, so this is called simple notification service. It can broadcast the message to multiple devices. It is a push based notification. You can do this to your Apple mobile, Google, or Fire OS, Windows devices, as well as some Android. Besides pushing a cloud notification directly to the mobile, SNS also delivers notification by SMS as a text or your email or to SQS or even to any other link. SNS allow you to group multiple recipient using a topic. Now in SNS again, it's a popular service in cloud, very uh, good, favorite topic for interviewer. So we have used this service to send a notification to your mobile for your billing purpose, billing notification, right? So here are the topics. You have to create a topic. Okay, I'm creating a standard one. I'm not creating any other. Just create a topic. Topic is basically just like a group in your WhatsApp. Topic is just like a creating a group in your WhatsApp. So this is a topic, or you can call it group. Inside a group, you have to add a subscription. Okay, just write. You have to send a email. So just write an email ID. Even you can send it to mobile. Okay. Now you can see confirmation is pending. So I have added a email ID. You can add one more email ID. So until the owner of the email ID verifies that account, before that you will not be able to send the message to this email ID. They have to approve that do you want to receive the message email. Now on message you can just type the number and send the message as well. So now you can see in a given topic, my topic, I have created two. I have added two email ID. So you will receive an email ID. You will receive a mail for verification. Okay, just like this. Okay, if you confirm the subscription, then only you will receive the messages from this. If you are sending any message from SNS, so if you refresh, you can see this is confirmed. Now I can send a message. Okay, so subject test, subject test body. This is the email I'm sending, and if you just send the message, so all the people, all the recipient in this group, in this topic, will receive an email. So if I will refresh it, okay, so a test message will be delivered to my, you can see here, test subject. But in other email ID, I didn't receive a mail. You can see I have just received a confirmation mail. Until I confirm, the other message will not be delivered to my email ID. So that's why you need to confirm the message, and you can send to n number of recipient. It will send all recipients. So you have to create a group. So Amazon says that the message which you are sending will be preserved until all the recipient receive the message. So to prevent the message from being lost, all the messages published to SNS are stored redundantly across multiple quality zone. Benefit of SNS: instance push based notification, no pulling. It's a push based service. Okay, even you can have a flash message. Remember when you call someone and your balance get deducted, there is a flash message comes on your mobile, USSD mobiles, USSD message basically. So that is also you can flash using SNS. Simple API and easy to integrate with the application. Flexible message delivery over the multiple transport protocol. Just like SNS, SMS, you can send email, you can send SMS, you can send notification. So many options are there. Inexpensive pay as you go model with no upfront cost. With web-based, AWS Management Console offer the simplicity of point and click service. It's a very simple service. Now, difference between SNS and SQS, both are messaging service, but SQS is a pull-based service. SNS is a push-based service. You have to push a message, and in SQS you have to pull a message. That's the only difference generally asked in exam or interview. Any question? So that's it for today. Just let me stop the recording. I will show that how my domain is up now. So you can see if I'm entering this domain name, this is a website which I have hosted in S3. This is my S3 bucket. Okay, this is a S3 domain. This is a S3 domain. Now I don't want to use this S3 domain. I want this website to be used on my personal domain. Okay, so I have, this is my domain. I'll just enter now. This is my domain. There is no Amazon domain. You can see right now here Amazon domain. This is my domain. So how can we do that? We'll see on Monday. Okay, how can we connect our domain with our, or any other service to our custom domain? So it's a chargeable service. Again, you have to purchase a domain and you have to register the domain to Amazon. So each domain you register, it will be charged as $0.5 per month. Okay.